Hello there, and welcome to the Sleepumentary channel. Tonight, welcome to the quiet edge of night. Somewhere above the rooftops, beyond the thin hum of the world, there's a faint blur in the sky so dim you might mistake it for a passing cloud. Yet it isn't a cloud. It is the largest thing you will ever see with your own eyes, the Andromeda galaxy. To the naked eye, it looks like a ghost, a soft oval haze suspended in the constellation that bears the name of an ancient princess. On a moonless autumn night, far from cities and noise, it reveals itself to anyone patient enough to simply look. No telescope, no technology, only the dark and the time to notice. What you see in that moment is light that began its journey more than 2 million years ago, long before language, before fire, before anything we would call human. Each photon falling now upon your retina was born in a star so distant that its light has crossed the gulf of time itself. It left when the ancestors of humankind were still shaping stone tools beside African rivers. It has travelled through eras that saw continents drift, glaciers rise and melt, and civilizations appear and vanish all, so that tonight it might arrive here on your eyelid. The simplest act of looking up becomes a conversation with prehistory. Ancient astronomers saw the same blur and gave it names that blended reverence with confusion. The Persian scholar al-Sufi recorded it in the 10th century as the little cloud, writing by lamplight about a mystery he could not explain. Medieval monks copied those notes into manuscripts, unsure whether the faint glow was a flaw in the heavens or a secret sign from God. The Greeks imagined the surrounding constellation as a chained maiden, a symbol of both sacrifice and grace. The light has never changed, only our interpretation of it. Through the centuries, the ghostly shimmer was a patient teacher. It waited through empires, through revolutions, through the slow awakening of science itself. Each generation looked up and wondered what it might be, a spirit, a mist, perhaps a collection of distant stars too faint to separate. Even when the first telescopes were turned toward it, Andromeda remained elusive still, just a fuzzy patch, neither planet nor star existing quietly at the threshold of what our eyes could comprehend. Tonight, as you breathe and let the noise of your day dissolve, imagine standing where one of those ancient skywatchers once stood. No maps, no electricity, only the whisper of wind and the hush of the cosmos overhead. Imagine the wonder they felt seeing that faint oval glow, not knowing that it was a city of 1 trillion suns. That delicate light carries within it not only the memory of its own stars, but of everyone who has ever gazed upon it. Shepherds in Mesopotamia, philosophers in Athens, astronomers in Damascus, travellers in the high deserts of Asia, all saw the same shimmer, all touched by the same ancient photons. In that shared act of looking lies something quietly extraordinary connection. Across generations and continents, across languages and lifetimes, the same light has brushed human eyes again and again. It has been a mirror for our curiosity, a reminder of how small we are and how vast we can dream. And so, as you listen tonight, let your mind drift with that light across time, across silence, across the deep velvet of the universe. Let the blur sharpen in your imagination until you can almost feel the faint pulse of those faraway suns. The night will hold you as gently as it has held them for millions of years. Breathe. The universe is already speaking. All you need to do is listen. A neighbour made of 1 trillion suns. If that faint blur were suddenly to come into focus, the sight would take your breath away. What looks like a thumbprint of mist to the naked eye is in truth an empire of light, a vast spiral galaxy called Andromeda, stretching more than 220,000 light-years from edge to edge. It is our nearest great neighbour, a colossal island of over 1 trillion suns, each one burning with its own hue and heartbeat. Imagine standing far enough away to see it whole. The spiral arms sweep outward like ribbons of starlight, each arm a river of suns winding through black space. Between them lie dark lanes of dust, the shadows of creation, where new stars are still being born from cold gas and ancient debris. From its luminous core to its farthest rim, Andromeda glows as softly as a memory, its light strong enough to cross 2 million years of emptiness and still reach our fragile eyes. Through the lens of a telescope, its structure reveals itself in layers. The bright central bulge is crowded with old golden star survivors from the early universe, steady and enduring. Outward from that heart spiral, enormous arcs of pale blue, clusters of young, energetic suns that live fast and die young. Between them, faint pink smudges mark nebulae where hydrogen gas blooms into new light. The deeper astronomers look, the more intricate it becomes, like peering into the anatomy of eternity itself. And yet in all that immensity, there's something familiar. The Milky Way, our home, is not so different. We share the same spiral design, the same balance of chaos and order, of birth and decay. Andromeda is, in a sense, our reflection across the void, a mirror held 2 million light-years away. To study it is to glimpse what our own galaxy might look like from the outside, a glowing whirlpool suspended in the dark sea of the cosmos. The numbers almost defy language. 1 trillion stars, 1,000 billion each one, with its own gravity, its own temperature, its own possible system of worlds. If even a small fraction of those stars host planets, then Andromeda could contain more potential homes for life than there are grains of sand on every beach of Earth combined. A single human lifetime is less than the blink of one galactic rotation, yet the light from those distant suns continues to arrive steady and patient, as though time itself were breathing. For comparison, the human heart beats roughly 70 times per minute. In that same minute, Andromeda rotates imperceptibly by a fraction so small it will take hundreds of millions of years to complete a single turn. To us it seems frozen eternal, but if we could speed time until eons passed like seconds, we would see it pulse arms flowing and curling, like wave stars, drifting clouds, igniting darkness, collapsing into light. The galaxy itself has a heartbeat, just one measured in cosmic time, and in that difference between our fleeting pulse and the slow rhythm of 1 trillion suns lies something humbling. We are tiny, but not insignificant. Our heartbeat, our curiosity, our act of looking upward are all part of the same universe that spins Andromeda through its endless waltz. The rhythm of blood in your veins and the motion of those faraway stars are made from the same atoms, obeying the same laws, born from the same ancient fire. If you could stand on one of Andromeda's countless worlds and gaze back toward the Milky Way, you would see our home as just another faint blur in a foreign sky, a small misty oval in the dark. And perhaps someone there looking up at us would wonder the same things. Who lives on that distant spark, do they too feel awe? Do they also listen to the quiet pulse of creation and call it beautiful? In that symmetry, something remarkable happens. The cosmos folds inward, and distance becomes connection. The faint blur you see tonight, that pale shimmer on the edge of vision, is not only an object of study. It's a reminder that we belong to a living, breathing universe immense beyond imagination, yet still close enough to touch through light. So let your breath match the rhythm of your heart. Let it slow until you can almost feel that far-off pulse, 1 trillion suns turning softly through time. Between your heartbeat and the galaxies, there is only one difference: duration. The music is the same. The mistaken nebula. For most of human history, Andromeda was not a galaxy. It was a mystery. Long before we knew the word galaxy, people saw it through crude telescopes and called it what their eyes could manage: a nebula, from the Latin for cloud. And that is exactly what it seemed to be: a delicate smudge of luminous vapor hanging within the Milky Way's own vault of stars. In the 17th century, when Galileo first turned his handmade telescope to the heavens, the universe was still imagined as a single shimmering dome. Stars were fixed, points of light, planets were wandering ones, and anything that glowed but refused to focus, anything soft, milky or unresolved, became a nebula, a fog inside the night. The instruments of the time were fragile miracles: brass tubes, hand-polished lenses, and trembling wooden tripods. Through them, observers saw the heavens in shades of blur and flicker. A telescope was not a window so much as a magnified candle in the dark. It revealed more than the naked eye, but less than the truth. When astronomers like Simon Marius in 1612 sketched the Andromeda Nebula, they recorded it as an oval mist with a bright centre and fading edges, unsure whether it was a star forming a comet dissolving, or perhaps some celestial breath left over from creation itself. To them, the universe was still intimate. Everything they could see they assumed belonged to one grand system, the Milky Way, our cosmic home. The idea that other island universes might exist beyond ours was both mathematically dizzying and emotionally impossible. It would be like realizing that your entire world, your sky, your gods, were just one among countless others. And so they imagined. The 18th century became a golden age of cataloguing wonders. Charles Messier, scanning the skies for comets, kept stumbling upon these hazy intruders and wrote them down as obstacles, things to be avoided. His famous list, the Messier catalogue, included Andromeda as Messier 31, an object of annoyance to comet hunters, but fascination to dreamers. William Herschel, the musician turned astronomer who built his own giant reflectors, began to suspect that some of these nebulous patches were swarms of unresolved stars. But even Herschel, who mapped thousands of them, believed they were still embedded within our Milky Way vast, yes, but local. In that era, imagination had to fill the space where measurement could not yet reach. Painters drew the heavens as gardens of smoke. Poets called them celestial mists or divine vapors. Even scientists described nebulae in organic metaphors: the breath of God, the seeds of creation, the embryos of worlds. Without distance, every theory was a kind of faith. Andromeda became one of the most studied of these clouds. Some thought it was a star being born. Others believed it was one dying, expanding into a shell of vapor. To look at it through the instruments of the time was to peer into uncertainty itself, a luminous riddle without edges. Yet that misunderstanding was not failure. It was part of the process, the necessary dream before the awakening. Human knowledge often begins as a blur, a soft outline mistaken for something else. Only later, when tools sharpen and patience deepens, does clarity arrive. In a way, those early astronomers were not wrong. Andromeda is a kind of cloud, a cloud of suns, of planets, of possibilities. Their error was only in scale, not in spirit. They saw mystery and they honoured it the only way they could, by giving it a name and writing it down. When we look at their drawings today, fragile ink circles on yellowed paper, we are witnessing the infancy of cosmic thought. The lines wobble, the proportions falter, but the wonder is unmistakable. Even through the imperfect glass of their telescopes, they were reaching for something vast, something barely conceivable. And perhaps that's the truest continuity between their world and ours, the gap between what we can see and what we can imagine. The Andromeda Nebula, as they called it, was not yet a galaxy in their minds, but it was already a mirror for the human condition, luminous, uncertain, and full of questions waiting to be named. Hubble's revolution. By the early 20th century, the Andromeda Nebula had become a puzzle that refused to fade. Telescopes were larger now, gleaming steel domes replacing wooden tubes, mirrors wider than a man was tall, yet the mystery only deepened. Through the haze, astronomers began to see faint stars pricking the glow, but the question remained: were those stars inside our Milky Way, or far beyond it? At Mount Wilson Observatory in California, where thin desert air met the chill of night, a young astronomer named Edwin Hubble took up the challenge. The year was 1923. Hubble worked beneath the massive dome of the 100-inch Hooker telescope, the largest eye humanity had ever built. Each evening the dome opened like the lid of a watch, revealing the cold machinery of the heavens. Night after night, Hubble photographed the Andromeda Nebula on glass plates peering through the eyepiece as Earth spun beneath him. Then one night something subtle but extraordinary appeared, a single star within the nebula that changed brightness over time. Not randomly, but rhythmically. It pulsed. Hubble recognized the pattern instantly. It was a Cepheid variable, a kind of stellar beacon whose brightness cycles, predictably, allowing astronomers to calculate its true luminosity and from that its distance. Using the relation discovered by Henrietta Swan-Leavitt just a decade earlier, Hubble measured that star's distance and the result shattered the sky. It was far beyond the edge of the Milky Way, so far in fact that the Andromeda Nebula could not possibly reside within our galaxy. It was its own galaxy, a vast island universe separate and immense 2.5 million light-years away. In that moment, the scale of everything changed. Hubble's notebook from that night still exists. On the photographic plate next to the faint speck of the variable star, he scrawled 3 simple letters in pencil, VAR, short for variable. But those 3 letters marked one of the greatest intellectual revolutions in history. The known universe had just multiplied not by 2, but by billions. The Milky Way, once thought to be the whole of existence, was revealed as only one galaxy among countless others. Humanity had gone from living in a single city to realizing it was one metropolis among endless archipelagos of light. The shock was immense. Imagine the quiet hum in observatories around the world as news spread a mixture of disbelief and awe. Overnight, our cosmic home went from everything to almost nothing, a single spiral adrift among the infinite. For some it was exhilarating, for others unsettling. It was as if the universe had suddenly taken a deep breath, and we were small enough to fit inside its exhale. Hubble's discovery stands beside those rare moments when reality itself expands, moments when the human story bends to include a greater truth. When Copernicus moved the Earth from the center of creation, he did more than shift a planet. He shifted our perspective. When Darwin traced the origin of species to the long patience of nature, he stretched our lineage back to the dawn of life. And now Hubble had done something equally profound. He had moved the Milky Way itself from the center of existence, letting the night bloom into infinity. Astronomers began to speak a new language. The sky was no longer a ceiling, but an ocean. Nebulae became galaxies. Galaxies became common. The word universe gained depth, no longer meaning a single sphere but a living cosmos woven of billions of star systems. Hubble's quiet measurement had unrolled a new map of being, and in the silent glow of his discovery lay something deeply human, that strange mixture of humility and wonder that accompanies every true expansion of understanding. Each time we think we've reached the edge of knowledge, the universe opens another door. Each time we draw a border around our world, light slips beyond it. It is easy now to take this vastness for granted, to glance at photographs of distant galaxies and feel nothing but aesthetic pleasure. But to stand in Hubble's moment is to feel the vertigo of infinity itself. The stars did not change, only our perception did. The universe had always been enormous. We had simply not yet learned how to see it. So the Andromeda Nebula became the Andromeda Galaxy, no longer a cloud within our home, but another home entirely. And from that realization flowed the modern cosmos, galaxies clustering, colliding, birthing stars in endless cycles. We live inside the echo of that revelation still. When Hubble stepped out of the observatory that night, the desert air must have felt sharper, colder, wider. Above him, the faint oval of Andromeda glowed, just as it had for every generation, before unchanged, indifferent, eternal. But in that moment, something within humanity had changed forever. The blur in the sky had become a bridge to the infinite, light older than humanity. When you lift your eyes to Andromeda, you're not seeing the galaxy as it is. You're seeing it as it was 2.5 million years ago. Every photon entering your pupil tonight began its voyage long before the first human words, long before there were cities, pyramids, or even the idea of civilization. Each ray of light is an ancient traveler. It left a burning star in Andromeda, when Earth was a different planet, colder, wilder, silent except for wind and water. At that moment in time, the ancestors of humankind walked upright on the plains of Africa, carrying chipped stones in their hands. They had no fire yet, no art, no map of the stars, only the instinct to look upward. Perhaps one of them did for a moment, seeing the same faint smudge you see now, unaware that their gaze and yours would someday connect across eons through the very same light. 2.5 million years. That is the age of this glow. While that light crossed the void, ice ages came and went. Continents shifted, mountains rose and crumbled, oceans advanced then withdrew. Entire species appeared, thrived and vanished. The photons we now catch on our retinas have passed through an evolving universe, through dust clouds, magnetic fields, and the gravitational pull of countless other stars without losing their purpose to arrive here now as a whisper of the past. It is difficult for the human mind to hold such time. Our sense of history stretches only a few thousand years, our lives a few decades, but the universe tells stories in the language of millions. When we speak of the present, the cosmos only smiles. For light, the present is always a memory. Every time you look at Andromeda, you're peering into a kind of time capsule, not a museum of stone, but one of radiance. You're watching a moment frozen in light, a portrait painted by photons that departed when there were no pyramids, no names, no history. Those photons are older than our species, older even than the dreams that would one day name them. If we could rewind that light to its origin, we would see Andromeda as it was then, its spiral arms alive with young stars, clouds of gas coiling into new suns, comets, orbiting alien worlds. Somewhere perhaps, a civilization was just beginning or had already ended beneath the same light we now call ancient. Every shimmer we see is a message written long before our arrival, a postcard from the dawn of time addressed simply to whoever happens to be watching. And the sender, a trillion suns, patient beyond imagining. Astronomers sometimes speak of look-back time, the distance to an object measured not in space, but in years of light's travel. It's a phrase both technical and poetic. Look back. To observe the universe is always to look backward. The farther we gaze, the younger the cosmos becomes. Through telescopes we watch galaxies not as they are now, but as they once were, cosmic ghosts shimmering through their own history. Andromeda, then, is not just a neighbour, it is a time machine. When you see it, you're witnessing an era when the first sparks of humankind were only beginning to burn. The light touching you tonight began before there were fires in caves, before there was music or story, before there was anyone to imagine galaxies at all. There is something profoundly humbling in that realization. Every time you blink, millions of photons, messengers from the deep past, vanish against the warmth of your eye. Their long journey ends not in the vacuum of space, but in consciousness. The act of seeing becomes an act of reunion, ancient light meeting modern awareness. So the next time you stand beneath a clear night and find that dim oval in the sky, remember you are not just looking across distance, you are looking through time. The light that began when humanity was a dream has chosen this instant, this heartbeat to arrive. And in that quiet moment under the vast breathing dark, you and your stone tool ancestors are both present, joined by a single stream of light that has never stopped travelling home, the approaching giant. There is something quietly unsettling about the light of Andromeda. Most galaxies in the night sky are sliding away from us, their light stretched into longer, redder wavelengths by the swelling of space itself. The universe is expanding, almost everything is retreating. But not Andromeda. Its light runs the other way, blue-shifted, shorter, sharper, the telltale signature of approach. Across 2.5 million light-years, the great spiral is moving toward us at more than 200 kilometers every second, fast enough to cross the width of our moon in a heartbeat. Yet to our eyes it appears perfectly still. The movement is too slow to notice, too vast to feel. The collision it foretells is written not in minutes or years, but in millions of years, a slow inevitability already in motion. Imagine it an entire galaxy, 1 trillion stars, countless planets, the gravitational weight of suns, beyond counting, silently falling toward us. Not falling through space, but with it drawn by a bond older than both. Between the Milky Way and Andromeda lies a shared gravity, a kind of cosmic magnetism linking their fates. They are partners in an ancient dance drawn together through the emptiness like two tides reaching across the same sea. We live within that motion. It does not disturb the oceans, it does not shake the ground, and yet it is happening now, this very second. If you could somehow step outside the galaxy and look down upon it, you would see both spirals already leaning inward, their invisible halos overlapping like translucent ghosts. The space between them is shrinking imperceptibly, relentlessly. It is rare, this blue-shifted defiance. Almost every other galaxy we can observe is red-shifted, moving away as the universe stretches wider and colder. The great fabric of space-time carries them outward like dust on an inflating balloon. But gravity has its loyalties, and here it refuses to let go. Andromeda and the Milky Way are bound by a local promise, the pull of their shared mass, stronger than the push of cosmic expansion. Against the tide of the universe, they are swimming toward each other. In the language of astronomy, this convergence is simply motion, a line of numbers, a spectrum with its bands slightly shifted toward the blue. But in the language of imagination, it feels like something deeper, an invisible tide already underfoot. The ground we walk, the air we breathe, even the atoms in our blood are drifting not outward but inward toward a meeting written in the quiet geometry of the cosmos. Picture it as a vast slow heartbeat measured not in seconds but in epochs. Every century that passes brings Andromeda 22,000 kilometers closer the distance between Earth's poles. In the time it takes for a human life to begin and end, the galaxy edges nearer by a fraction of its own width, invisible progress toward an eventual embrace. There is something strangely comforting in this inevitability. The sky that looks so still is in truth alive with motion galaxies courting across time stars, orbiting like dancers' worlds moving through the music of gravity. Andromeda is coming for us, but not with violence. Its approach is more like the pull of a tide, slow, patient, unstoppable, a future already in motion beneath the calm of night. Perhaps that's why its faint blur has always felt so haunting. Even before we knew of velocities or Doppler shifts, perhaps some instinct sensed the truth that this neighbour was not distant but destined, that every photon it sends is part of a conversation that will one day end in union. For now, though, we wait. The tide continues to rise silent, as starlight invisible as breath. The universe expands, and yet here, between these two great spirals, gravity whispers a different story, not of separation but of return. The collision foretold. Astronomers have already watched the future unfold not through prophecy but through simulation. On supercomputers humming in quiet rooms, scientists have recreated the coming meeting of the Milky Way and Andromeda, tracing every gravitational thread that binds them. What they found is both terrifying and beautiful, a slow-motion collision that will remake the sky. 5 billion years from now, long after our sun has entered its final chapter, swelling into a red giant, Andromeda will fill the heavens. It will not arrive suddenly, but as a gradual blooming. First, the faint oval will grow night by night until its spiral arms stretch visibly across the stars we know. Then, as centuries pass, the two galaxies will begin to merge, not like solid bodies, but like two clouds of fire passing through each other. There will be no crash in the ordinary sense. The distance between stars is so vast that despite the collision, few will ever touch. Instead, gravity will reach out invisible hands, tugging and reshaping everything. The spirals will distort their arms, stretched into long, luminous ribbons. Whole clusters will be flung into intergalactic space, while others fall inward, drawn toward the centers where the two supermassive black holes circle each other like dark suns. To stand on a surviving world, if such worlds still exist, will be to witness a sky unlike any seen before. Imagine it, two great disks of stars overlapping, their spiral arms intertwined, glowing in pale gold and deep sapphire. Rivers of light flowing through the night, stretching from horizon to horizon. The stars of another galaxy blazing brighter than our moon. For our distant descendants, it will not be darkness that defines the sky, but radiance. As the galaxies merge, new stars will be born in furious numbers, the collision compressing gas and dust into brilliant nurseries. It will be a brief but spectacular renaissance, a cosmic fireworks display lasting hundreds of millions of years. The night will no longer be quiet, it will be alive, pulsing with the light of new suns. Eventually the chaos will subside. The spirals will lose their form, their graceful arms drawn into one vast rounded body, an elliptical galaxy glowing softly in the quiet aftermath. Astronomers already have a name for it, Milkomeda, a union of two giants and of two stories. The simulations show how over eons these changes unfold with eerie grace. The galaxies pass through each other once, twice each encounter, slowing them down until they finally merge and settle into equilibrium. It is a dance of unimaginable scale gravity, as choreographer time as the rhythm. Nothing rushed, nothing wasted. Every motion purposeful, inevitable. The timeline defies human imagination. From the first overlap to the final union may take more than 10 billion years. For us, it is a tale that begins now and ends far beyond the reach of memory. But time for the universe has never been in a hurry. And yet, there's something deeply human in this vision of cosmic collision. We see destruction, but also renewal. Stars torn apart, but others born in their place. Light scattering, then coalescing again into something new. The end of two galaxies and the birth of one. It is the story of everything, creation through transformation. When you look up at Andromeda tonight, you are not just seeing the past, you're seeing your future. The faint glow that has travelled across millions of years will one day merge with the light of our own galaxy. The sky we know, the constellations, the familiar shapes will all be erased, rewritten in ribbons of brilliance. But perhaps that is the universe's quiet promise: nothing truly ends it, only changes form. The Milky Way and Andromeda are not enemies on a collision course. They are partners slowly returning to one another after an eternity apart. So when you see that faint blur, remember it is moving toward you. Not as a threat, but as a reunion. The future of the sky is already written in its motion. One day our descendants will look up and see the heavens ablaze with light, and they will call it home. The birth of Milkomeda. After the long turbulence of collision, there will come a stillness, not silence exactly, but a calm so vast it can only be measured in eons. The spiral arms of both galaxies, once flung wide like ribbons in a storm, will settle. The stars will find new orbits, the chaos will slow into order, and from that luminous wreckage a single immense being will emerge, Milkomeda. No longer two galaxies circling each other in wary approach, but one an enormous elliptical shape, glowing softly in the dark. The graceful spirals of both the Milky Way and Andromeda will be gone, replaced by a smooth halo of stars. Seen from afar, it will look like a golden ember, suspended in infinite night bright, at the core fading toward a whisper at the edges. Inside that new galaxy, the legacy of both parents will remain. Our sun, if it survives, will drift in a new orbit around Milkymeda's center, perhaps further out, perhaps drawn closer. The stars that once belonged to Andromeda will mingle with those of the Milky Way indistinguishable, their light blending into a single glow. What were once two great histories will merge into one. At the heart of this newborn galaxy, the most dramatic act of union will unfold. Each of the colliding galaxies carries within it a supermassive black hole. Andromeda's perhaps 100 million times the mass of our Sun, ours about 4 million. As the galaxies fuse, those titans will spiral together in a slow tightening orbit. For hundreds of millions of years, they will dance invisible yet monumental, pulling in stars bending space-time itself. And then at last, they will meet. When two black holes merge, no light escapes, but something else does a ripple through the fabric of reality itself. Gravitational waves spreading outward at the speed of light, carrying the story of their collision across the cosmos. If any beings still exist in that distant future, and if they have the instruments to listen, they will hear it not as sound, but as vibration. The deep cosmic bass note of creation renewed. That final merging will mark not an ending, but a transformation. The energy released will not destroy the galaxy, it will settle it. The newborn Milkymeda will stabilize, glowing serenely in the darkness, its core pulsing with quiet equilibrium. We might be tempted to call it the death of the Milky Way or the death of Andromeda, but the universe doesn't understand death as we do. It knows only change. Every star, every atom, every orbit moves from one state to another again and again in a cycle without malice or mercy. The galaxies will not mourn their loss. They will simply become something new. Endings are the price of continuation. The hydrogen that once flared in one star becomes the oxygen that breathes in another. The ashes of supernovae become the dust that forms planets. The collapse of galaxies births new structures, new harmonies. In the great arithmetic of the cosmos, nothing is ever truly gone. And so Milkymeda will rise a single glowing testament to what happens when gravity and time conspire toward unity. Its stars will drift through calm long after the sun fades, long after Earth is a memory. Perhaps by then, consciousness somewhere somehow will have learned to wander among galaxies to witness this new light and call it beautiful. When we imagine that future, it feels distant beyond hope. Yet every night when you see that faint blur of Andromeda, you are glimpsing the beginning of that story. The process has already started. The tide is already moving. The Milky Way and Andromeda are not doomed to destruction. They are destined for transformation. In the quiet arithmetic of eternity, even collision becomes creation. Perhaps that is the universe's oldest lesson, that every ending is just another way of saying begin again. The architecture of spirals. Before the galaxies merge and the spirals fade, let us pause to admire their architecture. These graceful turning forms that have defined the beauty of the cosmos for billions of years. When we imagine a galaxy, we picture the spiral luminous arms sweeping outward like brushstrokes of light, each curve balanced between chaos and symmetry. To the eye, it looks like movement, as if the galaxy were twirling in slow motion. But the truth is subtler and more musical. The stars themselves are not locked into the arms like jewels on a wheel. They drift through them, coming and going, much as musicians pass through a melody. The spiral pattern is not a static thing, but a wave, a travelling rhythm of gravity and density that moves through the galactic disk, gathering gas and dust as it goes. Astronomers call it density wave theory, but you could think of it as the galaxy's heartbeat, a pulse that shapes the flow of creation. As this wave passes through a region, it compresses clouds of hydrogen gas, coaxing them to collapse under their own weight. The result is a burst of birth clusters of newborn stars lighting up like sparks along the crest of a tide. Behind the wave, those stars drift onward, aging, cooling and fading, while the wave itself moves on, creating the next generation. Thus the spiral arms stay bright alive with youth, even as their stars come and go. From afar, the arms look serene, gentle ribbons of light, but up close they are anything but quiet. They are nurseries of fire and motion filled with turbulent gas, newborn suns and powerful winds. Within them, stars 100 times the mass of our sun blaze in fierce blue light, their lifespans brief but magnificent. These blue giants flood their surroundings with ultraviolet radiation, illuminating the gas around them in pink and crimson, tracing the arms in glowing arcs that telescopes capture as ethereal beauty. Between these radiant lanes lie the darker ones, the dust lanes cold and opaque. They are the pause between notes, the silence between beats. Inside them, new stars are forming, invisibly cocooned within veils of carbon and ice. It is in these shadows that the future of the galaxy is written. The balance of light and darkness, of creation and stillness, makes the spiral a kind of cosmic symphony. Each arm a measure, each cluster a chord, each supernova a symbol, crash, echoing through the interstellar medium. To look at Andromeda, or our own Milky Way, is to see this music frozen in time, a song that lasts hundreds of millions of years per measure. Andromeda's spiral pattern, like the Milky Way's, contains several major arms, grand sweeping structures spanning tens of thousands of light years. Some are bright with active star formation. Others are ghostly, composed mostly of older, cooler stars that trace the galaxy's skeleton. From above, it resembles a whirlpool of starlight. From within, it would be a glowing horizon in every direction, a slow, perpetual dawn. In a sense, the spiral arms are the galaxy's memory. They record the passage of the density wave, the rhythm of compression and creation. They remind us that motion and stillness are never opposites, only phases of the same process. So when we call these structures arms, perhaps that's too simple. They are not limbs reaching outward. They are currents in a vast ocean of gravity, swirls in a cosmic symphony of birth and decay. Each arm plays its part, keeping time with the slow metronome of the universe. One day, when Andromeda and the Milky Way are finally one, those spirals will fade, their pattern dissolved into a smooth elliptical glow. The music will quiet, but tonight they are still turning still, composing their endless melody of creation. And if you close your eyes and listen, perhaps you can almost hear it not as sound but as rhythm, the measured pulse of a galaxy dreaming itself into being. The golden heart. At the center of Andromeda lies its oldest secret, a golden heart that never sleeps. Through telescopes it shines as a concentrated glow, a tight, brilliant knot of light surrounded by the softer spirals of its arms. To the naked eye it is a single blur, but in truth it is an empire of ancient suns, tens of billions of them packed so densely that their light blends into a steady radiance, as if time itself was smouldering there. These are the elder stars of the galaxy, survivors from its youth. Their colors tell the story, not the blue of hot new giants, but the amber and gold of age. These suns have burned steadily for billions of years, fusing hydrogen into helium in a long, patient rhythm. They are the living fossils of the early universe, the ones that saw Andromeda take shape, that watched the first spiral arms unfurl like newborn galaxies learning how to breathe. This central bulge, as astronomers call it, is the galaxy's gravitational heart. Its mass anchors the rotation of everything around it, the arms, the halo, the distant star streams. The stars here move at immense speeds, whipping around the core in orbits so tight they trace invisible circles of fire. Were you to stand on a world within that region, if such a world could exist, your night sky would never be dark. Every horizon would blaze with starlight thousands of times brighter than our own Milky Way's gentle band. Darkness would be a forgotten concept. The galaxy itself would be your day. But even among these elder suns, something strange awaits in the center, something darker. At the very heart of Andromeda, hidden within the glow, astronomers have found evidence of not one but two supermassive black holes, perhaps the remnants of an earlier galactic merger, locked together in an invisible embrace. Each is millions of times the mass of our Sun. Together they orbit one another in a gravitational waltz. Older than Earth itself, their steps measured not in seconds but in millennia. They circle closer with every turn, drawing in gas and stars feeding on light. The material that strays too near spirals inward, heating until it glows with fierce intensity. X-rays and ultraviolet fire, the dying cries of matter falling past the point of no return. Around them, stars whip in tight ellipses, flung and caught again, tracing invisible choreography written in the mathematics of gravity. To watch this unseen dance is to glimpse the universe's paradox that what we call destruction is also a form of balance. The black holes consume, yes, but in doing so they stabilize the galaxy around them. Their gravitational pull holds the surrounding chaos in order, their hunger giving structure to the stars. They are the silent conductors of this cosmic symphony, directing motion through absence, harmony, through collapse. The light from the bulge and the darkness at its core are two halves of the same truth, creation and annihilation intertwined. Together they form the beating heart of Andromeda, pulsing in slow, majestic rhythm. Every orbit, every star, every echo of radiation moves to that ancient pulse, a pattern that began before our world existed and will continue long after our sun has burned away. If you could listen, truly listen to the center of Andromeda, perhaps it would sound like a deep and endless note, the hum of gravity itself, the melody of stars orbiting in obedience to an unseen pair, a duet so old that even time has learned its rhythm. And in that sound, the harmony of light and void, of presence and absence, lies a quiet truth that even in the universe's deepest darkness something dances. The ghostly halo. Every great galaxy wears a cloak invisible to the eye, immense beyond imagination. Around Andromeda, that cloak stretches for nearly 1 million light-years in every direction, far beyond the luminous disk we can see. It is not made of stars, but of ghosts, tenuous gas drifting dust, and the mysterious substance called dark matter, which outweighs everything visible combined. This is the halo, the galaxy's unseen body, diffuse yet powerful, shaping the motion of every star within. If the brilliant spiral is Andromeda's face, then this halo is its breath, silent and vast, surrounding it, like a faint exhalation into the dark. Telescopes cannot see the halo directly. It does not shine. Instead, astronomers trace it through subtle clues, the way light from background quasars dims as it passes through, or how stars in Andromeda's outskirts move faster than they should, as if tugged by invisible hands. Those hands belong to dark matter, the hidden architecture of the universe, a gravitational scaffolding upon which galaxies hang like dewdrops on a cosmic web. The size of Andromeda's halo is staggering. If we could see it glowing, it would cover a patch of sky more than 100 times wider than the full moon. Its outer edge, faint and diffuse, likely touches the halo of our own Milky Way already. Think about that. Even as the visible galaxies drift toward each other across 2 million light-years, their unseen atmospheres are mingling now. Between the two rivers of hot gas flow filaments of charged particles exchanging energy across the void. It is in a sense a cosmic handshake made of plasma, a greeting between two giants long before their stars ever meet. This shared halo region is where the first whispers of the coming union occur. The atoms within it move slowly, slower than the wind through a quiet forest, but their presence is everywhere. A single cubic meter might contain just a few atoms, yet multiplied across millions of light-years, their combined mass outweighs all the stars we can see. And in that faint, unseen space, something intimate is already happening. The two halos overlap, merge, and exchange. They are blending their edges, preparing the way for the galaxies themselves to follow. Long before Andromeda fills our sky, its invisible breath is already upon us. Dark matter too is at work, that elusive, unseen web of gravity that binds the universe together. It neither glows nor absorbs light, but its presence can be felt in every orbit, every motion. The halos of both galaxies are laced with it, two enormous shadows entwined. If light is the visible story of the cosmos, dark matter is the quiet text beneath it, the paragraph we can feel, but not yet read. In this merging of halos, one can almost sense the tenderness of the cosmos, the way even vast and distant things begin with gentle contact. Before the spirals collide, before the stars flare and scatter, their halos have already met in silence. A slow, patient embrace. From Earth we cannot see this. Our instruments only hint at it, our equations sketch its outline. But in truth the meeting has begun. The Milky Way and Andromeda are no longer wholly separate. They are already one in the unseen. So the next time you gaze at that faint blur in the night sky, imagine what lies beyond the light, a vast, transparent ocean of gas and shadow drifting between galaxies. There in that invisible space the future is already unfolding. Two halos touching, two galaxies breathing the same quiet air of eternity, the warped disk and its scars. At first glance, Andromeda looks serene, a perfect spiral poised in elegant symmetry. But look closer and you'll see it isn't quite smooth. Its disk bends ever so slightly like a frozen wave mid-crest. The outer edges tilt upward on one side and downward on the other as if the galaxy were bowing under an ancient memory. That curve is no illusion. It is a scar, the lingering mark of long-forgotten encounters. Andromeda has lived a turbulent life. Over billions of years it has swallowed smaller galaxies whole, pulling them into its orbit, shredding them apart with tidal forces, and scattering their stars across the void. These devoured companions leave traces that never fully fade, ghostly streams of stars like strands of silk caught in a slow current circling the galaxy's outskirts. Astronomers call this process galactic cannibalism. It sounds violent, and in some sense it is, but in another it is the natural way of cosmic evolution. Galaxies grow by consumption. The strong absorb the weak. Gravity gathers what time disperses. In this endless cycle, destruction and creation are indistinguishable. Each time Andromeda absorbed a smaller companion, it was reshaped. The incoming galaxy tugged at its stars, bending its disk, twisting its arms. The result is the gentle warp we see today, not chaos, but a graceful afterimage of past collisions. The galaxy carries its history not in fossils or ruins, but in curvature. Every tilt, every ripple, every strand of displaced stars is a record of something that once was. Modern telescopes, with their exquisite sensitivity, have begun to map these stellar remains. Around Andromeda, dozens of such streams form vast loops, pale, tenuous bridges of light stretching hundreds of thousands of light-years into space. Some loop back toward the main disk, others fade into darkness, their stars too faint to trace. To the eye of the astronomer, they are fossils not of bones but of orbits, preserved in the galactic halo like ripples on a cosmic pond that never quite stills. One of the most beautiful of these remnants is known as the giant stellar stream, a curving ribbon of stars arcing beneath Andromeda's plane, the remnants of a small galaxy that ventured too close perhaps 2 billion years ago. Torn apart by tidal forces, its stars now trace the invisible flow of gravity, wrapping around the larger galaxy like a scarf of light. It is a ghost of motion, frozen mid-dance. If you could see Andromeda from afar, truly see it, not as a flat spiral, but as a living dimensional body, you would notice how its disk twists like a sheet of water struck by a breeze. The pattern is delicate yet immense, a memory rendered in starlight. To astronomers it is evidence, to poets a metaphor, a ripple that remembers the pebble long after the splash is gone. Andromeda's warped form is a reminder that galaxies like people carry the shapes of their past. Every encounter, every collision leaves its trace. The cosmos has no perfect circles, only survivors. Our own Milky Way bears similar scars, streams of disrupted dwarf galaxies still orbiting their stars scattered like embers. We too are a composite being stitched together from the remnants of smaller worlds. To look at Andromeda's bent disk, then, is to see our reflection. Another creature of gravity and memory marked by what it has absorbed. So when you gaze upon Andromeda's calm spiral, remember that beneath its elegance lies a history of upheaval, a body sculpted by time, collisions, and hunger. The galaxy is not a monument to stillness but to endurance. Its warped disk is not a flaw, it is a signature, the silent echo of ancient tides. Like fossilized ripples on a cosmic pond, those distortions remind us that even in the heavens, beauty is not born from perfection, but from the gentle persistence of motion long after the storm has passed. The companions. Andromeda is not alone in the dark. Surrounding the great spiral is a retinue of smaller galaxies, companions, followers, and remnants drifting through its gravitational field like a constellation of moons around a planet. Astronomers have counted more than 30 of them so far, though there may be dozens more too faint to see. Together they form a kind of miniature society in orbit around their colossal host. The most prominent among them are Messier 32 and Messier 110, two dwarf ellipticals easily visible in long-exposure photographs glowing softly near Andromeda's core. Messier 32 hangs close, almost clinging to the edge of Andromeda's spiral arms, while M110 orbits a little farther out, faint but distinct, its elongated shape showing signs of strain. These are not tranquil satellites. They are being slowly reshaped by the same gravitational tide that bends Andromeda's own disk. Messier 32 in particular is a survivor of intimacy. It may once have been a full-size spiral itself, stripped of its outer stars by Andromeda's gravity until only its dense, bright core remained. What we see today is the bare heart of a galaxy that lost everything but endurance, a fossil of light circling its conqueror. Its stars move in tight ellipses, racing through the gravitational field like sparks drawn to a flame. Messier 110, by contrast, still bears the scars of struggle. It is puffed and elongated, its edges ragged from Andromeda's pull. Streams of its stars have begun to drift outward, faint trails that in a few billion years will dissolve entirely into the larger galaxy. Its fate, like that of many others, is merge a slow assimilation into Andromeda's expanding halo. Farther out, faint dwarfs orbit in a loose asymmetric swarm. Some follow elegant ellipses, others trace paths tilted steeply above or below the main disk like errant satellites caught in complex resonance. They are small, each perhaps a few billion stars at most, but collectively they weave a pattern of companionship around their massive neighbour. Some are ancient with little gas left to form new stars. Others are still clinging to their primordial clouds, glowing faintly with bursts of blue where young suns ignite. Modern surveys have mapped these companions in exquisite detail, revealing streams and bridges of stars connecting them to the parent galaxy. It is a celestial ecosystem, each body influencing the others. The orbits are not neat or predictable. They evolve through interaction as Andromeda's gravity tugs and twists, reshaping each satellite's destiny. Over cosmic time, many of these small galaxies will not survive. They will spiral inward, torn apart by tidal forces, their stars joining Andromeda's disk, or halo, absorbed into the greater whole. And yet in their slow demise lies something deeply poetic. Galaxies, like people, do not exist in isolation. They travel with company, bound by invisible bonds of gravity and time. Even giants need companions, the small bodies that test their balance, shape their form, and share their journey. Without them, Andromeda would be different, less scarred perhaps, but also less alive. This interdependence echoes across scales. In the same way that planets circle stars and moons circle planets, these dwarf galaxies orbit Andromeda, each relationship nested within another gravity, linking everything in one grand hierarchy of motion. From the smallest dust grain to the largest cluster, nothing in the cosmos truly moves alone. If we could speed time forward and watch the next few billion years unfold, we would see this family draw closer, the satellites falling inward, merging one by one until only the central giant remains. The sky around Andromeda would grow quieter, its companions fading into memory, their light scattered across its arms, and yet their essence would remain. Every absorbed star, every lost fragment would still circle within the greater galaxy, their stories folded into Andromeda's own. So when you see the photographs, the great spiral flanked by two glowing ellipses, think of them not as ornaments but as relatives. Messier 32 and M110 are not mere satellites. They are Andromeda's siblings, children and ghosts all at once. Their fates are bound, their lives interwoven. Even giants, it seems, do not wander the universe alone. They move in company, held together by the quiet pull of gravity, that oldest form of companionship unbroken since the dawn of time. The invisible skeleton of dark matter. Behind every graceful spiral arm, behind every shining star and glowing nebula in Andromeda, there is something unseen, something that neither emits nor reflects light, yet shapes everything we see. Astronomers call it dark matter. It is not darkness as we know it, but rather the absence of knowing, an invisible presence that outweighs all the luminous material in the galaxy by a factor of 5. Without it, Andromeda could not exist in its current form. Its stars would scatter into space, flung outward by their own orbital momentum. But dark matter's gravity holds them in place, forming an unseen skeleton, a vast scaffolding upon which the galaxy's luminous body hangs. Every star, every cluster, every cloud of gas moves in silent obedience to this invisible framework. The first hints of dark matter came from motion, the way Andromeda spins. When astronomers measured the speeds of stars at its outer edge, they expected them to slow, as planets slow the farther they orbit from the sun, but they did not. Instead, the outer stars raced just as swiftly as those near the core, as if something massive yet unseen was holding them fast. That discrepancy, those stubbornly flat rotation curves, became the first evidence of a hidden force. It was not a trick of light, nor a measurement error. The same pattern appeared in galaxy after galaxy, an invisible mass revealing itself only through its gravitational pull. The stars were moving to a rhythm set by something no telescope could see, a cosmic scaffolding built not of atoms but of mystery. Imagine Andromeda's dark matter halo as a sphere of gravity, immense and weightless, enfolding the visible galaxy like a cocoon. Within it, the luminous spiral is just the bright skin of a far larger organism. The halo itself extends for hundreds of thousands of light years, merging at its edges with the Milky Way's own dark halo. Two invisible forms already overlapping, two gravitational ghosts, embracing before the galaxies touch in light. We do not know what dark matter is. We only know what it does. It bends starlight, it anchors galaxies, it weaves the large-scale structure of the universe, the cosmic web, across which everything else is strung like pearls on invisible thread. Some believe it is made of undiscovered particles, others suspect an entirely new law of gravity. Whatever the truth, dark matter reminds us that the universe remains profoundly unfinished in our understanding. It humbles us. Because for all our instruments and equations, we still cannot describe most of what exists. More than 80% of Andromeda's mass and of our own Milky Way lies beyond perception. We live quite literally inside a mystery. If we could see it, the view would be hauntingly beautiful. Andromeda's stars embedded in a vast translucent lattice, a gossamer web of gravity holding them in their slow, eternal dance. It would look almost skeletal, a framework of lightless matter underpinning the galaxy's glowing flesh. The stars are merely the lanterns. The dark matter is the structure that lets them shine without drifting away. In that sense, dark matter is not absence. It is foundation. It is the quiet architecture beneath existence, the reason there is form instead of chaos, pattern instead of drift. It is the hidden partner of light, the silent majority of the cosmos. And perhaps that is the deeper lesson Andromeda offers, that most of what holds the universe together cannot be seen. That the essential things, gravity, time, memory, love, leave no light of their own, yet shape all that glows. When we look up at that faint blur in the autumn sky, we're gazing not only at the stars, but at the outline of the unseen. A galaxy balanced upon an invisible skeleton of gravity, luminous only because the dark allows it to exist. And maybe, just maybe, that is the truest symmetry of all light and shadow presence, and mystery holding one another in perfect unending orbit, hydrogen and the making of light. If Andromeda has a pulse, it beats in hydrogen. The faint red-pink glow that telescopes reveal along its spiral arms comes from clouds of this simplest element, vast cold nebulae where new stars are born. To the naked eye, they are invisible. Through sensitive lenses, they bloom like blossoms of living flame, diffuse trembling incandescent with creation. Hydrogen is the most abundant element in the universe, the firstborn child of the Big Bang. It is also the raw material from which every star, every planet, every breath of air ultimately descends. Within Andromeda's glowing arms, this hydrogen drifts in immense clouds, light years across until gravity gathers it inward. The gas cools, condenses, and begins to spin. Denser regions form knots, then cores, then fire. When the pressure inside one of these knots becomes unbearable, fusion ignites, and a star is born. The newborn flares with blue-white light, its radiation tearing apart the veil of gas that once hid it. Stellar winds stream outward at hundreds of kilometers per second, sculpting the surrounding nebula into delicate arches and pillars. Some of these forms resemble coral reefs or tidal waves. Others stretch like fingers reaching toward the light. The beauty is only the surface of the violence beneath. Each star nursery is a storm, a chaos of motion, shockwaves, collisions, and heat. Yet from that turbulence emerges order a star, steady and self-sustaining, burning quietly for millions or billions of years. Around it, leftover dust and gas may condense again, forming planets, moons, and perhaps the beginnings of life. In this way, the red hydrogen clouds are not just decorations of the galaxy, they are its wombs. If you could hear them, perhaps they would sound like a heartbeat. The slow, rhythmic thrum of fusion igniting within the galactic womb. Each new star adds its pulse to the larger rhythm of Andromeda, a trillion silent heartbeats layered into one continuous song of light. The color of these regions, the delicate pinks and reds, comes from hydrogen atoms, excited by ultraviolet light from nearby hot stars. When an electron within a hydrogen atom jumps to a higher energy level and falls back again, it releases a photon of pure crimson light. Multiply that by trillions, and the galaxy blushes with creation. This is how the universe paints not with pigment, but with transitions of energy. Within those clouds, stars of every scale are born. Some will shine for billions of years like our sun. Others, the massive blue giants, will live briefly and die spectacularly, exploding as supernovas that scatter heavier elements into space. The oxygen you breathe, the iron in your blood, the calcium in your bones, all forged in the heart of such stars born from hydrogen and returned to it. Thus the cycle continues. Hydrogen becomes starlight. Starlight becomes dust. Dust becomes planets. Planets become eyes that look back and wonder. Each generation of stars enriches the next, each death a promise of future birth. And through it all, hydrogen, that humble atom, remains the thread connecting every form of existence. In Andromeda, as in our own Milky Way, this process never stops. Clouds collapse, stars ignite nebulae, expand and cool, and the ashes of the old feed the new. It is a perpetual respiration as the galaxy breathing through creation and decay. If you were to drift through one of those nebulae, say, the great NGC 206 star-forming region, you would see light, not as we see it from Earth, but as immersion. Surrounding you would be soft crimson haze pierced by searing blue suns and drifting curtains of gas. You would feel the pressure waves of stellar winds, hear them if space could carry sound, like the faint roar of an ocean that never rests. And in that vast trembling sea of light, you might recognize something achingly familiar, the rhythm of beginnings. The slow expansion, the steady pulse, the gathering of warmth, as if the galaxy itself were alive, dreaming new stars into being. In the end, Andromeda's beauty is not static, it is reproductive. Every filament of hydrogen is a promise of future light, every newborn star a heartbeat echoing through the cosmic womb. And so, the universe renews itself endlessly tenderly through the making of light. Bubbles and breath, galaxies like living things breathe. Their lungs are made of stars, their breath of energy and dust, and every so often they exhale. Andromeda's most powerful breaths are invisible to ordinary sight, vast bubbles of hot gas that stretch tens of thousands of light years above and below its disk. Discovered in X-rays by NASA's Chandra Observatory, these ghostly lobes glow faintly in high-energy light, evidence of something stirring deep within the galaxy's core. They are the remnants of outflows, colossal winds driven by either bursts of star formation or the feeding of the central black hole. When stars live and die in crowded regions, their collective supernovae release titanic amounts of energy, heating the surrounding gas and blasting it outward. Like the breath from a furnace, the outflow expands into the halo, carrying with it metals and dust, the seeds of future worlds. Over millions of years, these hot, buoyant plumes cool, settle, and fall back into the disk, restarting the cycle. In this way, Andromeda is not static. It inhales and exhales matter, energy, and momentum in great cosmic respiration. The pattern mirrors that of our own Milky Way, which also possesses such bubbles, vast lobes of gamma and X-ray light discovered in the 2010s and poetically named Fermi bubbles. Together, these paired structures remind us that galaxies are not quiet islands of stars, but dynamic ecosystems in constant conversation with their surroundings. The process begins in the crowded heart of the galaxy, where dense clouds collapse into new stars. These young giants burn fast and die violently, their supernova releasing shockwaves that sweep through the interstellar medium. The collective force of thousands of these explosions pushes outward, creating giant cavities, bubbles in the galactic gas. Each bubble is a signature of vitality, a record of the galaxy's last great exhalation. From afar, these outflows look almost biological, like the steady respiration of a sleeping creature. The galaxy draws in cool gas from its halo, ignites it into starlight, and exhales it again as heat and wind. The cycle regulates its temperature, redistributes matter, and prevents the core from overheating. Even across hundreds of thousands of light years, equilibrium is maintained through breath. If we could watch Andromeda's life sped up across billions of years, we would see it pulsing softly, glowing brighter during starbursts, dimming as it rests. Its bubbles expanding and fading like lungs, inhaling and releasing over cosmic time. Each breath spreads heavy elements outward, enriching the galactic halo. Each inhale draws new material in sustaining the rhythm of creation. The gas that once belonged to one generation of stars becomes the cradle for the next. Dust expelled by dying giants drifts through space until gravity gathers it again into clouds ready for rebirth. Nothing is wasted, nothing lost. Energy transforms, cycles returns. Seen this way, galaxies are not mechanical structures, but living systems, self-regulating, self-renewing, held in fragile balance between creation and release. Their winds and bubbles are like sighs, the quiet evidence of life on a scale too large for us to comprehend. Andromeda's bubbles, faint though they are, carry that rhythm, a slow, steady respiration written in plasma. If one could stand on a faraway world orbiting a distant star in its halo, the sky might shimmer faintly with that diffuse glow, a whisper of the galaxy's breath stretching across the dark. We tend to think of galaxies as eternal frozen swirls of light, but in truth they live, They burn rest and renew their outflows, a kind of heartbeat in the vacuum. The universe itself, vast beyond imagination, may be a single living rhythm, expansion and contraction, birth and decay, inhale and exhale. And so Andromeda breathes quietly, endlessly filling the dark with the soft pulse of cosmic life. Its exhalations become the next generation's raw material, its sighs the scaffolding of stars yet unborn. The galaxy lives not through permanence but through breath, a rhythm of creation and release, whispering through time the same lesson found in every living thing. To shine, one must first learn how to breathe. Supernovas and the chemistry of life. Every star is a factory, a furnace that forges the building blocks of everything we know. But it is in death, not in life, that a star gives its greatest gift. When a massive star reaches the end of its fuel, gravity takes back everything it ever gave. The core collapses, matter implodes, and in less than a heartbeat the outer layers rebound in a detonation so powerful it can outshine an entire galaxy. This is a supernova, the brief blinding punctuation mark in the story of a star. Andromeda, like all great spirals, is littered with the echoes of such explosions. Across its arms, astronomers have recorded the remnants, expanding spheres of gas, glowing faintly in X-rays and visible like ghostly signatures of creation through destruction. Within those expanding shells, atoms are forged in furious abundance. The heat and pressure of a supernova are so immense that lighter elements fuse into heavier ones: iron, calcium, nickel, gold, uranium, the rare and precious matter that makes up planets, oceans and living beings. Without supernovae, there would be no chemistry of life. The hydrogen that filled the newborn universe was too simple, too bare. It needed stars and their deaths to create the complexity we depend upon. The iron that carries oxygen through your blood was once the heart of a star. The calcium in your bones was born in a shockwave that tore a sun apart. The gold in your ring was forged in the last instant of a collapsing core cast into space as the star died. You're quite literally a collection of ancient explosions, atoms recycled from forgotten suns. The story of Andromeda's supernova is the story of us. After the blast, the expanding debris mixes with the galaxy's interstellar medium, those cold clouds of hydrogen and dust that linger between stars. Over millions of years, the enriched material cools, condenses, and forms new generations of stars and planets. Each cycle adds new ingredients to the cosmic recipe: more carbon, more oxygen, more complexity. Slowly, the universe learns to make life. Astronomers call this process galactic chemical evolution, but it is in essence the same principle we see in nature, everywhere: renewal through transformation. The universe recycles itself. The ashes of one generation become the seeds of the next. In Andromeda's great star-forming regions, you can almost see this cycle frozen in light. Bright blue clusters, young, newly formed suns lie beside the faint glowing remnants of ancient explosions. One generation illuminating the death of another. The symmetry is breathtaking, almost tender. Creation and destruction holding hands. If you could drift within one of those supernova remnants, say a few thousand years after the explosion, you'd find yourself surrounded by expanding filaments of glowing gas, each thread a different color representing a different element: crimson hydrogen, emerald oxygen, golden sulfur. It would be like floating inside a cosmic stained glass window, each panel a memory of the star that was. Eventually, that expanding cloud will fade into invisibility, its atoms scattering through the galactic wind, merging with other clouds, joining new cycles of formation. One day, somewhere in Andromeda or the Milky Way, those atoms might coalesce into another planet, another ocean, another living being who looks up and wonders. There is a deep humility in that realization that everything alive owes its existence to death, that every breath is borrowed from the remains of stars. When we say we are stardust, it is not poetry, it is literal truth. The universe does not merely surround us, it composes us. We are its voice, briefly awake. And so as you gaze at Andromeda, at that faint smudge of light crossing the night, remember what it really is: a vast laboratory of becoming. A place where stars live and die, where atoms are made and unmade, where the elements of future life are already being prepared. The galaxy is not distant from us, it is within us. Its chemistry runs in our veins, its ashes are our inheritance. In the quiet rhythm of supernovae, the universe writes the oldest truth it knows, that from every ending something new begins to breathe. The spectrum of seeing, the Andromeda we know, is only a fragment of the real Andromeda, a single note in a symphony too vast for human eyes. What we see through our telescopes, that faint silver spiral against the dark, is merely the visible slice of its story, the narrow range of wavelengths our species happens to perceive. But beyond those wavelengths, the galaxy continues singing in colours our eyes cannot hear. Astronomers have learned to listen to that fuller song. They build instruments that see what we cannot, telescopes that read the universe in radio waves, infrared warmth, ultraviolet fire, X-ray storms, and the fleeting flashes of gamma rays. Each of these forms of light peels back another layer of truth, another version of Andromeda. Through radio waves we glimpse its skeleton, long filaments of cold hydrogen gas, stretching far beyond the visible arms tracing the architecture of future stars. These radio maps reveal the raw material of creation in visible rivers of hydrogen that connect Andromeda to its neighbours like veins across the cosmic web. In infrared, the galaxy glows with the warmth of dust, the gentle heat of star-forming regions cocooned in their nebular wombs. Here, what is dark to us becomes luminous newborn stars hidden behind veils of gas unseen by optical light, now revealed in soft amber radiance. In ultraviolet, Andromeda transforms again, blazing with the hot blue-white glare of young stars, each less than a few 100 million years old. This view captures vitality, the galaxy's restless youth, its bursts of renewal and creation. It is Andromeda at its most alive. X-rays tell a harsher story. They show the violence, the remnants of supernovae, the radiation from binary stars tearing each other apart, the furious glow of matter spiraling into the central black hole. In this light, the galaxy is no longer serene but wild, a storm of energy and collapse. And in gamma rays, the highest energy light of all, we find the whispers of cosmic rays, subatomic particles accelerated to near the speed of light, born from events too extreme for imagination. Few photons reach us, but those that do are messengers from the galaxy's most secret places, the frontier where physics itself bends. Each wavelength offers a truth, but never the whole truth. The visible light of Andromeda is like a single sentence from a vast book. Only when we read it across the spectrum from the longest radio waves to the shortest gamma bursts does the story come alive in full dimension. Science teaches us this humility, that the world is always larger than our senses, that reality hides behind filters of perception. What we see is never all that is there. The same is true of everything, not just galaxies, but people, ideas, moments. Every truth exists in layers. Every light reveals only part of the whole. We understand by combining perspectives, by listening in more than one colour. Perhaps that is the quiet philosophy hidden in Andromeda's spectrum, that no single light tells the entire story. That wisdom lies not in choosing one wavelength, but in seeing through all of them, even the invisible ones. When the instruments fall silent, when the last telescope closes its eye, Andromeda will still be there, radiant in every colour, even those we'll never know. And in that eternal radiance, the universe continues to whisper its most generous lesson. To seek understanding, we must learn to see beyond ourselves. The long argument of astronomy. Every great truth in astronomy begins as an argument. The night sky may look still and eternal, but our understanding of it has never been either. Each discovery has been a step in a long, slow debate between imagination and evidence, a dialogue that stretches across centuries, carried by people who dared to ask whether the universe was larger than anyone had dreamed. Andromeda has stood at the centre of one of the longest and most beautiful of those arguments. For centuries it was a mystery wrapped in haze, a faint patch in the constellation of the Chained Maiden, catalogued but not understood. Some thought it a cloud within our own galaxy, others suspected something greater. But without proof, it remained a question suspended in light. The 18th and 19th centuries brought new tools, telescopes of polished brass and glass lenses so large they strained their own mounts. Astronomers like William Herschel and Lord Rosse peered through them and saw other nebulae scattered across the sky, many with spiral forms. The question deepened: were these simply nearby clouds of gas, or island universes, entire galaxies beyond our own? By the early 20th century, the debate had become fierce. On one side stood Harlow Shapley, who argued that the Milky Way was vast enough to contain everything, that Andromeda was merely a distant internal cloud. On the other side, Heber Curtis insisted that the universe must be far larger, and that Andromeda was another galaxy entirely. Their public confrontation in 1920, the Great Debate, became a milestone in the history of science. Two men beneath the same sky, armed with data and conviction, reaching in opposite directions toward truth. Then came the photograph that ended the argument. In 1923, a young astronomer named Edwin Hubble peered through the 100-inch Hooker telescope on Mount Wilson and found within Andromeda's mist a single pulsing star, a Cepheid variable. By measuring its rhythm, he could calculate its distance. The result shattered every map of the cosmos. Andromeda was not a nearby cloud. It was a separate galaxy millions of light years away. The universe had suddenly expanded 100,000-fold overnight. Hubble's discovery turned wonder into measurement. But it also humbled humanity. For the first time, we realized we were not at the center of all things, not even at the center of our own galaxy. The Milky Way was one island among countless others, drifting in an ocean of darkness. From that revelation came others, the recognition that all galaxies are moving away, that space itself is expanding, that the universe has a history, a beginning, and perhaps an end. The great debate gave way to the great awakening of cosmology. Yet even these triumphs were human stories of rivalry, persistence, and awe. Hubble's calculations were refined by Henrietta Leavitt's quiet genius. It was her discovery of the Cepheid period-luminosity relation that made his measurement possible. Vesta Slipher's spectrographs provided the first clues of galactic motion, and countless others, often uncelebrated ground mirrors, built instruments, calibrated plates, and recorded numbers late into the night, all in service of this unfolding truth. The history of astronomy is not a march of certainty, but a conversation across generations, an argument conducted with patience, wonder, and humility. Every observer inherits both the questions and the errors of those before them. The data change, the instruments sharpen, but the spirit remains the same: to look farther, to listen harder, to be willing to be wrong. And so Andromeda became not just an object in the sky, but a mirror of our curiosity. Each time we looked at it more clearly, the universe grew larger and we grew smaller yet more connected. The debates that once divided astronomers are now part of a single ongoing dialogue, a long argument written in light between ignorance and discovery, between pride and humility. When we gaze at Andromeda tonight, we inherit that argument, the courage to question what seems obvious, and the grace to accept that our understanding will always be incomplete. For in the end, astronomy is not about certainty. It is about listening to the night sky as it disagrees with us, and learning to find beauty in the correction, the cosmic measure of distance. How do you measure the immeasurable? How do you stretch a ruler across the stars, across distances so vast that even light takes millions of years to arrive? Astronomy's greatest quiet triumph is that we learned how. And the first rung on that long ladder into the universe was found in a heartbeat, the rhythmic pulse of a special kind of star. They are called Cepheid variable suns that breathe in light. Their brightness swells and fades with astonishing regularity, each cycle a kind of stellar metronome. Inside them, layers of gas expand and contract under competing forces of heat and gravity. When the outer layers swell, the star cools and dims. When they contract, it brightens again. The pattern repeats days, weeks, sometimes months, but always with perfect rhythm. That rhythm turned out to be a key. In 1908, working quietly at Harvard College Observatory, Henrietta Swan Leavitt studied hundreds of these pulsating stars in the small Magellanic Cloud. She noticed a hidden order: the brighter the Cepheid, the slower its pulse. The relationship between period and luminosity meant that by simply measuring how fast a Cepheid beats, one could know how luminous it truly is, and by comparing that to how bright it appears from Earth, its distance could be calculated. It was one of the most elegant discoveries in the history of science, a bridge between the local and the infinite, built from light alone. Years later, Edwin Hubble would use this principle to measure the distance to the faint pulsing star he found in Andromeda. Its heartbeat told him that the galaxy lay millions of light years away, far beyond the Milky Way's boundaries. From that single pulse of light, the scale of the universe expanded overnight. Every modern measurement of cosmic distance, every galaxy cluster and supernova traces its lineage back to those same stars. Astronomers call it the cosmic distance ladder, and the first rung still rests on the steady breath of Cepheids. Above them come other tools, redshift standard candles, gravitational waves, but without those first pulsing lights, the ladder would never have left the ground. There is something profoundly poetic about that. The universe, vast and cold, revealed itself through rhythm, through repetition, through the simple constancy of a star's light. In the dark silence of space, it is the closest thing to a heartbeat. When we speak of measuring galaxies, what we are really saying is that we have learned to count their heartbeats to listen to the universe pulse in slow, steady time. Each Cepheid's light curve is a record of that pulse, a signature both mathematical and musical. It tells us where we are in relation to everything else. Perhaps that is why the discovery feels so human. We too navigate our lives by rhythm, the beating of hearts, the ticking of clocks, the cycles of breath. Somewhere deep inside, the pattern of a Cepheid resonates with us. It is a rhythm we understand without needing to explain. The distances between galaxies are not measured in kilometers or miles, but in light years, and thanks to Cepheids we might also say in heartbeats of light. Each pulse marks another step outward, another rung on the ladder between what we know and what we still hope to understand. When Henrietta Leavitt looked at those faint flickering dots on a glass plate, she could not have known that she was giving humanity its first true sense of scale, teaching us to hear the rhythm of the cosmos itself. And so the universe became measurable, not through conquest or power, but through patience, through the quiet observation of a star that knew how to keep time. The cosmos is vast beyond words, yet it beats with a rhythm that mirrors our own. Light expands, fades, returns a heartbeat across eternity. The galactic ballet, even from 2.5 million light-years away, Andromeda moves with purpose. Every star within it, from the newborn blue giants at the tips of its arms to the aged red suns in its golden core, is part of a single coordinated dance. The galaxy turns not as a rigid wheel, but as a living ballet, its performers tracing arcs across the dark on timescales beyond imagination. One full revolution of Andromeda's spiral arms takes about 200 million years. When last it completed a turn, the dinosaurs still ruled the Earth. When it finishes the next, the continents will have shifted again, and perhaps the descendants of humanity will watch it slow spin from a different world. The galaxy's motion is not chaos. Its spiral arms hold their shape thanks to a delicate rhythm, a gravitational choreography that governs the speed of stars as they orbit the center. Those nearer the core race ahead. Those farther out drift more slowly. Yet the pattern of the spiral, the wave of density moving through the disk, endures. It is as if an invisible metronome ticks somewhere deep within the galactic heart, keeping perfect time for creation itself. Each orbit sets the tempo for stellar birth and death. Clouds of hydrogen drift through the arms like dancers waiting their cue. When they enter the denser regions of the spiral wave, they collapse and ignite, forming new stars that blaze for a brief act before fading into embers. Behind them follow the remnants, white dwarfs, neutron stars, black holes, partners bowing out as the next generation takes the stage. Seen from afar, the motion looks serene. But inside, the choreography is immense, hundreds of billions of bodies moving in synchrony, every star responding to the pull of all the others. Gravity is the composer, the stars, the orchestra, like the music we can see. If one could stand above the galaxy and watch it in time-lapse, it would appear as a slow whirlpool of light arms curling and uncurling like ribbons, supernova flashing like percussion clusters, glowing like crescendos. Every beat of that rhythm takes millions of years, yet the pattern holds precise, patient, eternal. The galaxy's rotation curves its stable spiral density waves. Even the oscillation of its warped disk are all measures in this cosmic score. Nothing is random, everything is resonance. The universe, it seems, keeps time on scales we can barely conceive, ages, measured not in seconds or years, but in revolutions of galaxies. When you look up at Andromeda tonight, you are seeing one frame of an infinite dance. The stars you see now are mid-step, following a rhythm that began long before us and will continue long after we are gone. The galaxy turns slowly, endlessly, as if keeping time for creation itself, a vast silent waltz where light is both dancer and song. And in that rhythm, steady and sure, there is comfort. Even across millions of years, the universe remembers how to keep time. The local family Andromeda is not an island adrift alone in space. It is part of a quiet congregation, a local group of galaxies bound together by gravity and slow companionship, moving as a family through the dark. At the heart of this gathering are two giants, the Milky Way and Andromeda, each surrounded by their own retinues of smaller satellites, faint dwarf galaxies, tidal remnants, and ancient companions still circling in fragile orbits. Between them, a faint third member, the Triangulum Galaxy, smaller but luminous, perhaps the younger sibling of the three. Around these larger bodies drift dozens more than 50 known dwarfs, some barely holding enough stars to be seen at all. They move in quiet patterns around the giants, their paths shaped by mutual gravity. Some are being pulled apart, their stars stretched into threads. Others have already merged, leaving only faint trails as evidence of their brief independence. Together, this collection forms a gravitational neighborhood about 10 million light-years wide. Within it, space itself is still balanced between the outward expansion of the universe and the inward pull of shared mass. It is a fragile equilibrium, a floating archipelago of light surrounded by infinite dark. If you could see the local group from far above, you would witness a slow and stately motion, each galaxy orbiting the group's common center of mass, drawn together like ships circling an unseen anchor. The Milky Way and Andromeda. The twin captains of this fleet are already moving on converging trajectories, destined to merge in 5 billion years. The smaller galaxies follow in their wake, bound to join their eventual union. And beyond this small family lies the next destination, the Virgo cluster, an immense assembly of thousands of galaxies whose gravity tugs on us all. The local group is slowly drifting toward that greater congregation, carried along by the gentle current of the cosmic web. It will take tens of billions of years to reach it, a voyage so long that even the stars themselves will change before arrival. For now, though, we drift together, a family of galaxies sailing side by side through the darkness. Between them lies mostly emptiness, vast reaches of intergalactic space, where light rarely passes, where the nearest neighbor is measured in millions of light years. Yet the pull remains. The invisible threads of gravity keep each member tethered, however faintly, to the others. It is comforting in a way to imagine this community of worlds, a cluster of galaxies journeying together through a silent universe. From within the Milky Way, we see only a few of our companions, faint and far away. But from afar, the pattern is clear, a family bound not by proximity but by motion, by heritage, by shared destiny. The local group is a tiny corner of the cosmos, but within it unfolds the same story that governs the whole universe: attraction, collision, transformation, renewal. It is a model of cosmic kinship, galaxies forming, fading, merging, and yet remaining parts of one another's history forever. And perhaps, as our two great spirals inch closer together across the gulf, there is something tender in their fate. Two ancient travelers drifting for eons, now approaching reunion, their entourages following like children returning home. In the end, the local group is more than a cluster of stars and dust. It is a reminder that even in the deepest night, nothing truly moves alone. We sail together, bound by invisible ties through a universe vast enough to hold us all, from clusters to superclusters. Step back farther than the span of galaxies, farther even than the slow orbits of the local group, and the night begins to change again. What seemed infinite a moment ago becomes small, and a new pattern reveals itself. The Milky Way and Andromeda, along with their faint companions, belong to a greater congregation called the Virgo supercluster, a sprawling realm of galaxies that stretches more than 100 million light-years across. Within it lie thousands of clusters like ours, each containing hundreds of galaxies each, a city of stars drifting through space. And beyond even that, these superclusters themselves are not scattered randomly. They are connected, strung together by vast bridges of matter and void. In this far perspective, the universe begins to look almost biological. The galaxies trace long, glowing filaments, vast tendrils of light and gravity woven through the dark. Between them lie immense cosmic voids, regions so empty that whole galaxies could drift through without encountering a single atom. Together, these filaments and voids form the cosmic web, the grand architecture of everything that exists. If you could see it all at once, the pattern would take your breath away. A lattice of light, millions of light years across, stretching in all directions, like the branching of neurons or the roots of an ancient tree. Each filament glows faintly with galaxies, clusters of stars like beads on invisible strings. At their intersections lie the superclusters, the bright nodes of this galactic nervous system. We live inside one of these filaments, our own local group, clinging to a strand that runs through the outskirts of the Virgo supercluster. The nearest filaments connect us to others, the Hydra Centaurus supercluster, the Coma cluster, and beyond, forming an unbroken structure that spans the observable universe. It is a map of relationships, not isolation. No galaxy, no cluster, no supercluster exists apart. Every structure is bound to the next by gravity, each filament a bridge of invisible matter, connecting one glowing island to another. The cosmic web is the universe's handwriting, the script of formation traced by gravity, time, and the faint breath of the Big Bang itself. In the deepest sense, these filaments are the nerves of the universe. Through them flow the forces that shape everything. Gravity, dark matter radiation, the silent currents of expansion. The universe, vast and cold though it seems, is threaded through with connection. Each galaxy is not a separate spark, but a neuron in a cosmic mind still unfolding. When astronomers map this web, they speak of its beauty with reverence. It is both structure and story, the memory of how matter cooled and gathered after the birth of time. The patterns repeat at every scale, from the spiral arms of galaxies to the filaments between clusters, self-similar, recursive, alive with symmetry. And within those threads flows the material of existence, atoms forged in ancient stars, drifting across space to seed new worlds. Every breath of air, every grain of dust, every spark of thought is in some quiet way part of that same network. From the smallest molecule to the largest supercluster, everything belongs to a single continuous tapestry. The cosmos does not end at the edge of sight. It simply weaves itself into finer and finer threads. If you could step back far enough to see it all, every filament, every cluster, every glowing node, the universe would look not like emptiness, but like a living organism, luminous, interconnected, pulsing with energy. And in that vision lies a simple, humbling truth. We are not separate from the structure of the cosmos, we are expressions of it. The same threads that bind the galaxies also bind us. We are filaments of light thinking about light, nerves of the universe briefly aware of themselves, mirrors of life. When we look toward Andromeda, we see only the sum of its stars, the faint collective glow of 1 trillion distant suns. Yet somewhere in that soft blur, worlds must exist. Statistically, inevitably, mathematically, planets circle those suns just as ours circles this one. Astronomers have long suspected that Andromeda's stars host exoplanets by the billions. Even with our finest telescopes, we cannot yet pick them out, they are too faint too far. But we can imagine them guided by the same physics that shaped our own neighborhood. Rocky planets in gentle orbits around yellow dwarfs, gas giants trailing moon systems of ice and cloud, frozen wanderers drifting through the dark between stars, rogue worlds, exiled but still carried within the galaxy's vast gravitational embrace. Somewhere within Andromeda's spiral arms there may be habitable zones, narrow rings of warmth where liquid water could persist, where chemistry might play the slow game of evolution. Perhaps there are double sun skies there where dawn comes twice and shadows overlap. Perhaps there are oceans glowing under unfamiliar constellations, and eyes biological or mechanical that have turned outward toward the tiny point of light that is us. It's a dangerous and beautiful thought that while we wonder about them, something in Andromeda might be wondering too. Two civilizations separated by 2.5 million years of light's delay, gazing across time at each other's ancient selves. Their present is our Stone Age. Our present is their prehistory. Every photon that crosses that distance is not just a messenger of light, but of memory. And yet this speculation must rest in humility. For all our searching, we have found no proof of life beyond our world, only hints, only possibilities. The silence between the stars is not absence, but distance. A distance so great that even a shout made of light arrives long after the speaker is gone. Still, science allows, even encourages wonder. There are more planets in Andromeda than there are grains of sand on every beach of Earth. Among them must be those that mirror us in some quiet way, worlds with mountains and clouds, with rain, with the occasional improbable spark that learns to ask questions. Life is not guaranteed, but neither is it rare. The chemistry of curiosity may simply be what the universe does when given enough time. So perhaps on one of those unseen shores another mind looks up at a night sky and notices a faint blur barely visible, and wonders what is that. Perhaps they give it a name. Perhaps they dream of traveling there just as we do. And perhaps they too have storytellers who speak softly at night, imagining what it would mean to be seen. Across 2 million light years, we may already be exchanging questions, light for light, thought for thought, unaware that the conversation began long before either side existed to continue it. And if no one is there, if the galaxies remain silent and unmirrored, that too is a kind of answer that the universe entrusted its awareness to us, if only for a while, and asked us to listen in its stead. Either way, when you look toward Andromeda tonight, let the question linger, unspoken, unsolved, unhurried. Could someone there be watching us? The communication of light. If someone is there, if eyes or instruments or minds within Andromeda have ever turned toward us, then we are already in conversation. But it is a conversation conducted at the slowest possible speed, the pace of light itself. Across 2.5 million light-years, even the universe's fastest messenger moves with glacial patience. Every photon we see tonight began its journey before humanity existed, before language, before art, before anything that could be called memory. The light that leaves Earth tonight in turn will not reach Andromeda until long after our species is gone, perhaps long after our planet itself has changed beyond recognition. If an Andromedan civilization aimed its most powerful telescope at Earth right now, what would it see? Not cities, not satellites, not radio chatter. It would see Africa as the cradle of early humans, small fires flickering across the plains, stone tools striking sparks. To them, we are still becoming. And when their light reaches us millions of years from now, we will be equally ancient or perhaps long silent. This is the great paradox of cosmic communication. Every exchange is an echo of the past. No true dialogue can ever exist across such distances, only the mutual reading of one another's fossils in light. The universe converses not in words, but in patience. In a way, every photon is a letter written long ago. The galaxies are pen pals separated by epochs sending their stories through the dark on a medium that never accelerates. The cosmos is filled with such messages, ancient, unwavering, perfectly punctual. It just takes time, unimaginable time, for their answers to arrive. Even our most ambitious signals, the radio pulses we've sent into the void, will spend millions of years wandering before reaching even the nearest galaxies. And when they arrive, they will be mere whispers drowned by the noise of creation. Still we send them, because to speak even without reply is a kind of hope. Perhaps that is the deeper lesson Andromeda offers, that distance does not silence, meaning it simply stretches it across time. The light between galaxies is not emptiness, it is correspondence. Every beam, every ray, every photon is part of an unending conversation that began with the first stars. If the universe could be said to have language, it would be this light, traveling through darkness, refusing to forget where it came from. We will never exchange words with Andromeda, not in any ordinary sense. But the dialogue exists regardless, written in photons, preserved in motion, bound by the simplest promise of physics that once something shines, it can never unshine. So when you stand beneath the night sky and let Andromeda's ancient light fall upon your face, know that you are part of this slow, patient communication, a single receiver in a network older than memory. The universe is speaking gently across millions of years. All we must do is listen and wait. The chemistry of continuity. Everything your heartbeat, your breath, the calcium in your bones, the iron flowing through your blood was forged in the fire of stars. Andromeda, like our own Milky Way, is not just a collection of suns. It is a vast factory of matter, an ongoing experiment in transformation. Every star begins the same way, a cloud of hydrogen collapsing under its own gravity, igniting fusion in its core. For millions or billions of years, that fusion continues hydrogen into helium, helium into carbon and oxygen, and so on, each step an act of quiet creation. When those stars die, they scatter their elements back into space through stellar winds or supernovae enriching their surroundings. This is the chemistry of continuity, the way a galaxy renews itself through death and rebirth. The material from one generation of stars becomes the raw material for the next. Andromeda's luminous arms are filled with such cycles, ancient stars fading while nearby new ones ignite from their ashes. Within those arms, the galaxy is not merely shining, it is becoming. If you could drift through one of Andromeda's nebula fields, you would feel it a sense of motion that is not just physical, but chemical. Each wisp of gas carries atoms that have lived many lives, oxygen that once burned in a red giant carbon, that once glowed in a nova iron, that may someday circulate through another world's blood. The boundaries between stars, planets, and beings are temporary. The matter itself endures endlessly recycled. Our atoms share that same history. Long before they formed you, they belonged to stars that lived and died in the Milky Way, and before that to even older galaxies. When Andromeda and our galaxy eventually merge, the atoms from both will mingle indistinguishable. Your iron, your oxygen, your carbon will one day join that greater fusion, another link in the long chemical chain of existence. Astronomers call this process galactic enrichment. Poets might call it memory, the way the universe remembers itself through matter. In the language of science, every atom heavier than hydrogen owes its existence to stellar fusion. In the language of wonder, every breath you take is borrowed starlight transformed and returned. Andromeda's role in this cosmic cycle is both specific and universal. It forges the same ingredients we know: carbon for life, silicon for stone, nitrogen for air. It does so not for us, not with intention, but with fidelity. The laws of physics repeat themselves there as they do here. The universe practices continuity. The same reactions, the same songs of fusion played in countless variations across billions of galaxies. And yet there is something personal in that knowledge. When we study Andromeda's spectrum, those faint lines of colour in its light, we read the same elemental fingerprints that compose our bodies. Hydrogen, oxygen, carbon, iron, the same alphabet written in different handwriting. It is as if the galaxy itself were whispering, "We are made of the same story." In that realization, all distance dissolves. 2 million light-years no longer feel like separation but kinship. The same atoms once scattered by stars have merely taken different routes through space before arriving here in us, in our thoughts, in the eyes that now look back toward their origin. The chemistry of continuity is the universe's quiet assurance that nothing is ever lost, that every particle will one day shine again. And perhaps as we gaze at Andromeda's pale light, what we're truly seeing is the reflection of our own matter travelling home, the galaxy as a heartbeat. If you could watch Andromeda not for one night or one lifetime, but across millions of years, you would see that it breathes. Its brightness waxes and wanes, its arms shimmer with waves of star formation that bloom and fade like slow tides. To us, these changes are invisible, far too gradual for human eyes. But through the patient instruments of astronomy, the pattern becomes clear: the galaxy has a pulse. Every few 100 million years, Andromeda brightens slightly as a new generation of stars ignites within its spiral arms. Hydrogen clouds collapse, fusion begins, and the galaxy glows a little stronger. Then, as those young blue giants die and their light fades, the glow dims again. Creation and rest, expansion and quiet, a rhythm older than our planet. The galaxy's center also flickers, though subtly, an irregular heartbeat of high energy, bursts from its twin black holes, brief and faint pulses of X-rays that ripple through the core. Even in its heart of darkness, Andromeda does not sleep. It inhales and exhales light on scales too vast for any single being to perceive, but the rhythm is there, patient, steady, eternal. To imagine this heartbeat is to sense the flow of time on a universal scale. One cycle of Andromeda's pulse might last longer than all of recorded human history. Each flash of starbirth could span the rise and fall of countless civilizations. The galaxy's tempo is so slow that our entire species appears, flourishes, and disappears between beats. And yet the rhythm endures unhurried, perfect. Astronomers see it in the infrared glow of newborn stars, in the ultraviolet signatures of their deaths, in the gentle modulation of the galaxy's light across centuries of observation. The fluctuations are small fractions of a percent, but taken together, they form a pattern of living balance. Energy flows in, energy flows out. Even galaxies obey the pulse of equilibrium. If you compress billions of years into a single breath, Andromeda would seem to shimmer a luminous heart, contracting and expanding each wave of light, a promise that the universe never truly rests. Creation is not an event, it is a rhythm. And as our own galaxy moves toward Andromeda, we too are drawn into that pulse. Two great spirals approaching one another across the dark, their heartbeats slowly syncing the future, Milky Way already learning to keep a shared rhythm. Perhaps that is the truest measure of cosmic time, not in seconds or centuries, but in cycles of radiance and repose. Galaxies breathe, stars flare and fade, light journeys outward and never returns, and somewhere in that endless rhythm between the bright and the dark, the living and the still, we find our own heartbeat, fleeting, fragile, and yet perfectly in time with the stars. Looking back from Earth, you don't need a mountain observatory or $1 billion telescope to find Andromeda. On a clear autumn night when the moon is down and the air is still, you can see it from an ordinary backyard, a faint oval blur just beyond the constellation Cassiopeia's tilted W. At first, it seems barely there, a smudge on the sky's dark canvas, but the longer you look, the more it gathers shape, as if the universe rewards patience with revelation. That ghostly shimmer is light that began its journey 25 million years ago. Each photon striking your eye tonight left its star when our ancestors were shaping tools from riverstone. It has crossed the empty gulfs unbent and unbroken to finish its voyage inside your retina. In that instant, you become part of the story, the receiver at the end of a message older than humankind. Amateur astronomers know this intimacy well. With a modest telescope, even one small enough to rest on a tripod, Andromeda stretches across the eyepiece, its bright core, its misty arms, the faint satellites of M32 and M110 drifting nearby. Some spend hours guiding a camera's slow exposure, collecting photons one by one until the ghost becomes a spiral of living light. When the image appears on the screen, delicate blues faint rose hydrogen clouds, it feels less like taking a photograph and more like opening a time capsule. Each frame is a conversation between human hands and cosmic patience. The electronics record what a naked eye cannot. The heart registers what mathematics alone could never say. Every pixel contains centuries of wonder, every color, a fingerprint of elemental truth, hydrogens pink, oxygens teal, starlight's white. Professional observatories add their own layers, the Hubble Space Telescope resolving individual stars' radio dishes, mapping cold hydrogen infrared cameras tracing dust. Yet the backyard image and the spaceborne mosaic are versions of the same actolite meeting consciousness after an impossible journey. Think of that the next time you stand beneath the sky. The faint blur you see is not just an object, it is an arrival. The universe has been sending this message for millions of years, and tonight in one quiet corner of Earth you are its reader. The hum of distant traffic, the cool air on your skin, the soft click of a camera shutter, all of it happens in the present. But the light you're capturing belongs to the age before language. To photograph Andromeda is to hold prehistory in your hands, to bridge the gap between what was and what is. It is proof that astronomy is not only science but intimacy, a shared heartbeat between cosmos and witness. A single human eye gazing upward becomes the final instrument in a chain that began with a star, and somewhere within that faint glow, the universe is still writing back, the threshold of wonder. And now we arrive where all journeys of knowledge end not in answers but in awe. After all the light years, the mathematics, the telescopes and theories, we find ourselves back beneath the quiet sky, looking up the same way our ancestors did, the same way our descendants will. The Andromeda galaxy is still there, faint and patient, rising over rooftops and forests, whispering through the cold autumn air. It asks nothing of us but attention. We cannot reach it, cannot hear it, cannot truly comprehend its scale, and yet in seeing it we are changed. We have measured its distance in heartbeats of light, traced its motion through space, watched it breathe and merge and transform. We have imagined its worlds, its stars, its future union with our own. But beyond all that knowing lies something quieter, the feeling that to witness is enough. Science, at its gentlest, is an act of gratitude. Every photon that reaches us is a gift freely given, a fragment of time that has travelled across the void just to say I was here. To study it is to listen. To wonder at it is to respond. The galaxies do not need us to notice them. But perhaps the noticing itself is what makes us fully alive, the way curiosity anchors us in the infinite, reminding us that we belong to it, that the same atoms, which burn in distant suns, once burned in other hearts, other skies, and now in ours. There is comfort in knowing that mystery endures. The universe is not a puzzle to be solved, but a relationship to be kept, a long conversation between light and awareness, between what exists and what can wonder. So let the questions remain open. Let the distances stay vast. Let the silence between galaxies continue to hum. Because in that silence, in that not knowing, we are closest to the truth of who we are, temporary shapes of matter, briefly aware of eternity. As Andromeda drifts closer across the ages, our two galaxies will one day merge, but long before that their light has already touched. The space between them, between us, is filled with connection. And perhaps that is the gift of all this, to see the universe not as distant but as kin. To remember that we are made of the same light we spend our lives trying to understand. So breathe. Look up once more. Let the faint blur in the night sky remind you that time is vast, that patience is holy, and that wonder is never wasted. Because perhaps, just perhaps, mystery is how the universe keeps us awake to wonder. Thank you so much for keeping me company tonight. Don't forget to subscribe so we can share many more stories together.